Okay, we now move to the case of the difference between two population proportions. So now what we have is two categorical variables, each with two categories. So we're going to look at perhaps the proportion of males and females that are in favor of a particular political position or candidate or whatever. Our parameter will be PA minus PB, the difference between two population proportions, and the statistic will be P hat A minus P hat B, the difference between two sample proportions. This is a problem. If you've printed it out, you already have this. We'll kind of go through it at any rate somewhat quickly, but we have 200 employees at a retail company and 200 employees at a civil service organization, and we're looking at the question we were asking is, do you view performance appraisal as an activity that lacks fairness and transparency? So of the 200 civil service employees, 136 said yes, and of the 200 retail employees, 124 said yes. And we want to know if there's a difference, so it's going to be a not equal to a two-tailed test. You might have, and it would be reasonable, I think, actually to do a one-tailed test for the simple reason that you think that maybe more civil service employees will have these views about performance appraisal, mainly because it's more difficult to measure performance in civil service than it would be in retail, where you can just look at number of units sold or something like that. That might actually make it less or more transparent and seem more fair. But anyway, in this case, we're just going to look to see whether or not there is a difference. And then here's just a graph of the difference. And you can see here, this is the 136 out of 200 civil service employees viewed this as unfair and not transparent. So out of 200, that means we have 0.68. That just is 136 divided by 200. And then we had 124 of our retail employees who also thought it was not transparent and unfair, and that's 0.62. Remember, this is P hat A, and this is P hat B. So our statistic is the difference between those, P hat A minus P hat B, 0.68 minus 0.62, or 0.06. So that is our statistic in this case, a difference of 0.06. Our hypothesis, as we've been doing previously, will always be in the form of an HO and an HA, where HO is the hypothesis of no difference, that PA is equal to PB, or restated in the same way as PA minus PB is equal to 0. I think for a lot of people it's easier to think about PA equal to PB and PA not equal to PB, but when you get to the graphing this and the sampling distribution, it's nice to have the 0 here, because you're going to put a number on the sampling distribution and that number will be 0. And of course, if the proportions are equal, then the difference is 0. So we're going to reject HO if the p-value is less than 0.05. So this again is just exactly the same as it was when in earlier problems. Now I'm assuming, I don't think I stated in the problem, and if I don't, or just in generally people use 0.05. No real reason other than history for that, but usually you use either 0.05 or 0.01. So let's just assume, unless not stated, that we'll use 0.05. Anyway, reject HO if the p-value is low. That'll be our alpha, or level of significance, 0.05. On the two sample tests, I'm going to let you use, and actually recommend that you just use calculator or statistical software to do the calculations for you. So to get the p-value, You have your TI 83 or 84, select Stat, then arrow over to Test, arrow down to 2 proportion Z-test, and then from there you'll just enter the numbers from the problem. If you need to pause during this, as usual, please do so. So when you do put the numbers in, it'll be for Group 1, or Group A, the calculator will call it Group 1, 136 out of 200. For Group 2, it's 124 out of 200. And then we selected not equal to for the alternative hypothesis. Unlike the one sample test, you won't have to enter a null hypothesis. Your calculator assumes that you're looking for a simple difference and that that's always 0. You could do differently than that, but most texts don't, and we won't in this class. If you do that, you should see a p-value, and please do verify that you see a p-value of 0.208. Now when we do get to our sampling distribution, we won't have to double this. This is the entire p-value, as long as you selected not equal to when you completed the form, since this is a 2-sample test. We said we would reject HO if the p-value was less than 0.05. It's not, so we will fail to reject HO. Since we failed to reject HO, we conclude that there might not be a difference in the population proportions of civil service and retail employees who perceive performance appraisal as unfair and not transparent. So all I'm doing here is putting in words, in context of the problem, the conclusion of the study.